All right, today we're going to be talking about linear functions. Linear functions should be an easy lesson, I think, anyway. Linear stuff I've been doing for a long time, since junior high, so nothing too strenuous about this section. F of x equals mx plus b is the normal setup for that. For a linear function, what is normally the domain? Yeah.
Good morning, AHS. Please rise for the Pledge of Allegiance.
Let's pledge
I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation under God, indivisible, with liberty and justice for all. Please remain standing for a moment of silence. Thank you. Please hold for announcement. All teachers with first block planning, please head to the CTE conference room at this time.
All right.
So here's a reminder, the FAFSA deadline is February 1st. That is coming up this week. We will be having our last scheduled FAFSA event tomorrow in the library from 3 until 5. If you cannot make it to that event and you need help filing your FAFSA, please contact me or have your parent contact me to set up an appointment to get help in completing that application so that you can stay promise eligible no matter what your plans are after graduation. Thank you.
All right. Seniors, make sure you take care of that. It's important. The range of a linear function. Yeah, it's the same. There are no red flags in there. Remember, our red flags are division by a variable or a square root in the problem. So with a linear function, none of that's happening. So typically, those are your domain in the range. Where that can change is when you get into the context of a word problem. And you've got to think about what's going on in context of that problem. Can you make a negative profit or something like that, which is possible. But, or if the domain is talking about, people, can't have negative people, right? It's either zero or a positive. So that can change depending on the word problem situation. But just a regular linear function, those are the things that are going on. So let's review a few concepts that you've done before. First one is function value. So here's our function f of x. We'll start with something 3x minus 7, something pretty easy. And they want us to find f of negative 2. What do we do? Yeah, put a negative 2 in the place of x and work it out. Be negative 6 minus 7, negative 13. So f of negative 2 is negative 13. What does that create? An ordered pair. It's x values too. So these are the same thing as an ordered pair. Negative 2, negative 13. Those are the same thing. So be able to tie those. Make sure you're tying that together, that ordered pairs exist there. Kind of in the same idea with function value is they could ask you for the same thing, find x when f of x is equal to, let's do negative 21. So what are we doing there? Do what now? Set the whole thing equal to negative 21 because we're replacing f of x with negative 21. So that's going to be 3x minus 7 equals negative 21. And then we solve that for x. So add 7. 3x is equal to negative 14. Is that right? And then divide by 3. And just so happens it's a fraction, but that's okay. We want to reduce it as far as possible, but leave it improper. Don't make it a mixed number. Don't change it to a decimal. Leave it as that. So we get the x value. And in the same way as example A did, that still creates an ordered pair out of that. So they give you a y value, you can find the x value to get the ordered pair out of it. They give you an x value, you can definitely find the y value to get that out of there. So some basic function value things that you've definitely done before. All right. Next idea. Intercepts. So let's say we have g of x equals 2/3 x plus 5, and they want us to find the intercepts. What does that mean? Where it crosses the x and the y axis, so both of those. That's all we're finding there. So if we're going to find the x-intercepts, that's the harder one. We'll do that first. How do we do that? Yeah, anytime, no matter what kind of functions we're dealing with. This section dealing with linear functions, but if we're dealing with quadratics later on this chapter or higher degree polynomials, the whole idea of an x-intercept is you set the function equal to 0 and solve it, and that's going to get us the x-intercept. So 2/3 x equals -5 multiplied by 2 or 3/2 -15/2. We get an x-intercept at 0 or at -15/2, 0. So an ordered pair is how we want to list those x-intercepts as ordered pairs. And then the y-intercept, much easier thing. You plug a 0 in for x. Since it's already in slope-intercept form, when I do that, I already know that the y-intercept is going to be what? 5. I said 5, I wrote 5. Instead of x, I'm going to put 0 in the place of that, but it didn't really matter. So it's 0, 5. We'll end up for the y-intercept. So x-intercept, y-intercept, we're plugging those in the appropriate area and working that out, finding those intercepts. Really easy to do. Can get a little bit more interesting just because you forget these from time to time. If we had h of x is equal to 8 is my function, and they ask for the intercepts. That was weird, right? But what are they? 0, 8 is the what intercept? So the y-intercept is at 0, 8. What's the x-intercept? Doesn't have one, so it's none. How's that? What do we know the graph of that looks like? Horizontal line across at 8 on the y-axis. What's the domain of that? Negative infinity to positive infinity. What's the range? What constant? What's the range? Just 8. So your domain, you guys add that on the spot, is from negative infinity to positive infinity. The range, because it's a horizontal line, it's going to be 8. And you use brackets because it's included there. So that's didn't ask for that in the original problem, but just being aware of those things is very important, just so that you're getting there. We talked about this in chapter 3 a little bit. Average rate of change is the slope. Since we're dealing with linear stuff, if it's in slope intercept form, we already have that. The college kind of style of writing that would be delta y over delta x. and then function notation. Just the slope formula like we already know, always known though. So linear models, if we've got data and we want to find the equation for the given data. And they give us, let's example E in it. They give us a table. I'm going to do it in horizontal form here, just save a little space. 20, 50, 30, 47.5, 40, 45, 50, 42.5, 60, 40, 70, 37.5. They give us that data there, and they want us to write the equation of that data. How do we do that? Pick two ordered pairs and write the equation of the line out of that. I'm going to pick a couple of easy ones here. I'm going to pick these two just for demonstration. This data does come from a linear function, so don't. This is not necessarily line of best fit. It's just so I'm going to do 50 minus 45 over 20 minus 40. Negative 5 or 5 over negative 20 is negative 1/4. So slope's 1/4, negative 1/4. How do we find the y-intercept? Take an ordered pair and plug it in. I'm going to use one of the two that I made that slope from. I'm going to use that 20/50. That looks easy enough. So in the y, I'm going to put 50 in the place of x. I'm going to put the 20. And b is now the only variable in the problem. So that gives me negative 5 plus b, 50. 55 is equal to b. So the final answer is this function f of x is equal to negative 1/4 x plus 55. On a quiz or a test, if I'm asking you to do that, I'm going to tell you which two ordered pairs to use just so that we're all finding the same equation instead of me just letting me pick and then I have to figure out possibly 23 different equations or not quite that many. So going by pair, depends on how many ordered pairs there are. But I would tell you which two ordered pairs to use out of that. All right. The next one's going to be a word problem. May be able to see that okay. I don't know. I tried to do the best. Took a picture of it with my phone and posted it in here. So this is actually on page 282 of your book if you want to bring that out. If you don't, that's okay. 282. It's example 4 in your textbook. Example F for us. But talking about book value of an asset that a company uses to create its balance sheet. Some companies depreciate their assets using what's called straight line depreciation, so that the value of the asset declines at a fixed amount every single year. It makes it easy to know when it's time to replace that particular asset. Think about in terms of cars, like we're dealing with here. Company has purchased a fleet of new cars for its sales force, and it costs $28,000 per car. And the company chooses to depreciate the vehicles using the straight line method over 7 years. This means that each car will depreciate at $28,000 divided by 7, $4,000 per year. So that's where they're coming up with that $4,000. They show you that's what's going on. They want us to write a linear function that expresses the book value V of each car as a function of its age X. Okay, so they want us to write an equation V of X equals MX plus B. That's what they're after, is at the end result. We're going to find the slope. We're going to find the y-intercept there. from this particular problem. And then they want us to graph that linear function. We're going to use the graphing calculator to graph it. And then what's the book value after 3 years? And then we're going to answer these questions here. So A part. Again, we're doing V of X equals MX plus B. What is the slope? 4,000, positive 4,000, negative 4,000. I heard both. Somebody give me a reason that says negative. Aiden, you said negative. Tell me why. It's losing value, so it depreciates. So that's a negative amount. So a negative 4,000. That makes sense. What's our y-intercept? Now, 7's the number of years. Think about where's the y-intercept happening? When x is what? 0. So that's at 0 years. What's the car worth at 0 years? 28,000. So it's brand new, right? When we first bought it. So that's where the B value is going to be 28,000 because that's the value when we bought the car. Haven't given it to a sales rep yet. Okay, we just bought it, put it out there. We're getting the stickers put on it with our name on it. Okay, so this would be our function for depreciating our assets using the straight line method. There are other methods if you take accounting. Sometimes when you get a little further into it, they start talking about different methods, but this one is pretty commonplace because the math's easy. All right. B part says graph it. So let's graph that thing. I'll show you how to manipulate your graphing calculator a little bit with this. So I'm going to clear out anything that I've got in my y equals, and I'm going to make sure I turn off my plots if I've got any on. And I'm going to type in that equation, negative 4,000 x plus 28,000. So that's big numbers. So when I graph that on the 10 by 10 window there, I must have some other equation going on. Nope. Negative 4,000x plus 28,000. Going on. All right. So what's happening, or how do I need to set my window on my graph? I'm going to hit the window button and our X minimum. What would be the minimum number of years? 0. Yeah, X min could be 0. I'm going to leave the X max at 10, even though we know we're depreciating it over 7 years. I think 10, that gives us just a little bit of space there so we can kind of see what's going on there. And my X scale, I can go by 1. That's fine. What about our Y minimum? I think a little space there, negative 10 is fine. Our Y maximum, though. What's our highest Y value? 28,000. So I'm going to go just a little bit above that. I'm going to set it to 30,000. And then I'm going to hit graph. And I see that graph happening there. Okay. So that's just changing the window in your on your graphing calculator so that you can see the graph look like what it should look like. Okay. We can see values as X gets further and further along. We're seeing the value go down at negative slope. It makes it make sense. So we can see that picture out of that. So if I wanted to take a picture of that, good. I'm going to copy that and put it in my notes there. But you know how to get there. Now, how do you get your calculator back to normal after you've done that? That's the part most of us kind of will want to do eventually. So how do you get your calculator back to the 10 by 10 window like we usually have? Anybody know? Zoom and Z standard, which is 6, option 6 there. If you hit that, it'll take you back to that 10 by 10 window. Okay, so Zoom 6 is your way back to the 10 by 10 window, which is where you're going to live most of the time. But when you get into these word problems, sometimes you got to change that X and Y axis a little bit so you can see your picture well. There is a little bit of a trick thing that you can do here. If you hit Zoom and then scroll on down past Zoom Stat to Zoom Fit, and you hit enter there, it will adjust the scale or adjust your X and Y axis a little bit. I don't like that picture quite as much because I don't have any control over it. Maybe that's just the teacher in me. I want to have control over things out of that. But it will adjust it to kind of fit what your graph is doing. I don't think that's as good a picture as what we did by setting our scale and things. And it doesn't make us think about context of the problem either. I think while we were talking about, we were thinking context of the problem that we're not going to go below 0 years. And here, they don't know that that's what's happening. They're just assuming you could have negative years. If you can, let me know. We'll develop a partnership. Maybe get into this whole time travel thing and see if we can make some money at it. All right. So, graphing it, getting your graph set up and back to normal. That's great. C part up there asks us to find the book value of each car after 3 years. So book value after 3 years is C part. So where does that 3 go? Yeah, they're asking us to find V of 3. That's all they're doing. Need much for that, 12,000. 28 minus 12 would be 16 grand. So after 3 years, we're saying the value of our cars is still $16,000. It's pretty good, I'd say. D part on the same problem asks us to interpret the slope. So that just means we're going to write a statement about what does that mean. So what's the slope of this problem again? Okay, what does that mean? You guys have said it already, but the value of the car decreases by $4,000 each. Very simple idea to interpret the slope out of that. And it's just in context of the problem that you have. E part says, when will the book value of each car be $8,000? And it gives us a hint there. Yeah, set the whole thing equal to 8,000. So 4,000x, 1,000x plus 28,000 equals 8,000. Be negative 4,000 equals negative 20,000. X would be 5 years. So same things that we were doing on examples A and B, but in the context of a word problem. So nothing is really strenuous about the word problems in this particular section. Just dealing with, how's it work inside of word problem. All right. Let's do what part are we on? G. Example G. Last one. We'll be done. Supply and demand. Supply and demand. What do we know about that? Maybe we've taken economics and learned supply and demand. What does that tell them? What do we know about those things? Okay, so the higher the supply, the lower the demand, right? So give me an example of a time when there is a low supply and a high demand, some sort of anything that relates to you guys that would be something that's the case. Say it again. Gas. Okay, so what happens when the supply of the gas is low? Prices go up. We see that at the pump, pretty regular. The prices are changing. Uh, they've been pretty steady for the last 3 years. I don't know where that came from, but anyway, they've been pretty steady. And but 8 years before that, they were kind of rocky and they went up a lot there at one point. And a lot of it depends on the situation in the Middle East and then how much gas we're producing from our own oil reserves as well. So when supply goes down, demand goes up, so the price can be raised up. When the supply is really high, the demand goes down, and the price goes down. We lower our prices so we can sell more of it, so we can still make our money out of that. So supply and demand goes there. So when you're dealing with supply and demand in this particular section, you're talking about equations of supply and demand. So we probably have some sort of supply equation where we're making something, we're building some sort of device, or maybe it's a phone or something like that. And we have a supply that tells us, okay, we're making these many phones out of that, or this is the cost of our production. And then we have a demand function. Okay, so this is supply and this is demand. So you're going to get a supply and demand function from your maybe a word problem. Maybe it's just a little small statement that says, here's your supply function, here's your demand function. And then they're going to ask you to do some things with that. One of the things they'll ask you to do is find the equilibrium price. What is an equilibrium in general? Okay. It's balanced, right? Okay, so you think about daughter in science class use those scales, or you had to put the weights in one side and you put whatever you're weighing in another, and you try to get it level out. So when it's equilibrium, it levels out. In mathematics, equilibrium would be what? What? When things are in equilibrium, they're what to each other? Equal to each other. So if it's an equilibrium price, then our supply must equal our demand. And that's like perfect case scenario. There's like we're meeting the demand and they're buying up everything we make. That's perfect case for us. So we're going to see what the price is that's going to hopefully make that happen. So we set the supply equal to the demand. So supply equals demand. That's what we're doing to get the equilibrium price. And we're solving that equation. Real easy math here. $75p equals $37.50. Divide by 75. The price at equilibrium would be that goes 50 times. $50. Whatever we're building here in the context of this problem, if we set the price at $50, then our supply and our demand meet up. That's a good place to be. Okay, so that's nice. What price creates a greater supply than demand? A couple of different ways to think about this, but there's a fairly straightforward way and one way that's a little bit more clever. But what could we set up as far as this goes? Yeah, set supply greater than demand. Real simple idea there, right? So 60p minus 900 is greater than negative 15p plus 2850. We've already done that as an equation, and we get p by itself, and yeah, p is greater than $50. So if we charge more than $50 for whatever we've made, then we're going to reduce the number of people buying it. That's what that means, right? And so if we reduce the number of people buying it, what happens? You get more of them piling up on the shelf or sitting back in the warehouse just waiting to be bought, okay? Because the price has outran our demand for that. But when it was $50, we were selling all of them we could make out of that. So same idea in the context of this. If it asks for what price will create a greater demand than supply, and you just flip the inequality symbol out of that. And anything, if we sell that thing for less than $50, then people are buying up everything we can buy, and then they want more out of that. So that can drive up the demand. So really easy concepts there. So nothing really hard in this section. All linear things, so nothing too strenuous when you go to solve things. Few that I need to cut off. How much? 284. One through 50 or 1 through 49, whatever you want to do. I'm gonna put 1 through 50 as the practice for that. There's several word problems in there in context of this. Again, don't overthink those. They're shouldn't be too strenuous when it comes to that stuff. And then one last thing before we turn you loose here. If you're looking at a set of ordered pairs like we had when we were writing that equation with average rate of change and all that stuff, what should be the same if it's a linear set of ordered pairs? Something's linear, should happen. What should be the same if it's linear as opposed to quadratic or some other wonderful type of. What makes something linear? The rate of change makes it linear, right? So the rate of change or the slope should be the same throughout your set of ordered pairs. So if you check the slope on the first two, and then check the slope on the last two, and they're different, then that's probably not linear, right? So rate of change or slope should be the same. You can also look at a scatter plot of those points if you wanted to plot them on a coordinate plane and see if they make a line. That works too. But that also checks the slope and the rate of change. So rate of change